Actually, I can sit on this side. Ramiro, what's going on, dude?
When did you leave Houston?
Oh, I flew back yesterday, dude. I flew back yesterday.
Yesterday I sent you a message. I don't remember what
I saw the pozole, dude. You sent me the picture of the pozole, dude. It looks so good.
Yeah, the menudo.
The menudo, dude.
That's better.
I needed some of that, dude. I was hurting the next day.
Yeah.
I was, dude.
I was gonna call you, but I didn't know if you was busy or anything. I was like, let's just hope he sees it.
You're good. I saw it.
He's in Houston.
I saw it, but yeah, no, I was kind of leaving. I spent Easter with my family, and then then I flew out the next day. That show was crazy though, dude. That show was absolutely crazy. The one I played.
I was trying so hard to go.
Dude, yeah, I had tickets for you, dude. I had guest lists for you, dude. I sent it to you.
I saw you messaged me, and I was trying so hard to go. I was already ordering an Uber from over there from the theaters.
Oh yeah, but yeah, that was at like 12:15 or something. What's up, Equity? Yeah, you hit me at 12:45. I'd already finished playing, and then like we were heading back pretty soon. But did I send you the address for the after hours? We had an after party till like 9 a.m. man.
Damn.
We were absolutely ridiculous.
I was drinking.
What's up, Grimmy?
Much that day.
Yeah.
Where was my invite to after party?
Oh yeah, no, I should have, Grim. I'm sorry, dude. I thought you were with your brother. No, I sent your brother the ticket because he's at least 18 and it was 18 and up. He could have come to it, but I thought he'd tell you about the after party as well.
No, because the after party you didn't tell me till way late.
Oh, I screwed up. My bad. I'm sorry. Like, yeah, I was on such an adrenaline fix after like I finished playing that like I totally didn't know what was going on. Yeah. Yeah, I know. Well, hit me up, Grim. You know where I'm at, dude. But yeah, no, this was the show I played. It was absolutely nuts, dude. One sec, I'll pull it up. It was pretty cool. What was it? This was the flyer for it. This was me with my manager. We got a little goodies. This is my buddy, dude. He was too funny, dude. But then this was me on the stage. It was really cool.
I hear your manager, not your manager.
Yeah. I was playing in Houston, dude. I was playing in your city, dog.
Yeah.
I played some Lil Nas X for you guys too.
I was gonna bring you some Jack Daniels and everything.
Dude, we had plenty of liquor, dude. Did not even. This was sick, dude.
More is always better.
I prefer beer compared to liquor.
I agree.
I prefer liquor compared to beer.
Dude, we went through like 14 bottles that night, dude. It was nuts. I probably got some videos of me with like champagne or something at some point.
It be like that.
This is my buddy's Lambo. My buddy's got a Lambo too. We did a whole photo shoot. What's up, Equity? Oh, I saw Mondo there for a second. But yeah.
How fucked up were you the next morning?
Pretty. Yeah, a lot. Yeah, what happened?
How was the hangover?
It was the worst. What's up, Nick? Good to see you. I'm testing out this new Elgato prompter, Nick, that Zev got me. I'm gonna see if it's cool.
When did Taco Cut become mod?
I don't know, a week or 2 ago, 2-3 weeks ago. I needed some mods, and he was doing really well. He was doing a very good job.
Still mod.
Nick's Grim's still mod, dude. He's still mod. What's up, Jermaine?
That's how.
Oh, I see. This shakes my camera if I do this. Ooh. We gotta figure out how to stabilize that.
Party, that's how.
I switched to tits to Twitch. Yeah, what's up, Mondo? Yeah, Mondo, have you seen this thing? Have you seen this the Elgato prompter? My boy Zev.
What's up, Obama?
Yo, Grim. Ramiro.
What's up?
What's up, Obama? Obama's here too. My friend got me one of these for my birthday. Well, my birthday's on Friday, but yeah, this thing's it's super cool. So like, man, we love switching to tits. I switched to tits to Twitch. Yeah. But yeah, no, it's cool. Cause I can see the chat like as you guys are talking on here, and it's pretty cool. But
Obama up. He doesn't talk, swear.
No, Obama's here. He's talking, dude.
He's not talking. He's muted.
No, he's here.
No, I'm not talking.
Dude, he's here, dude. He's here. What are you talking?
Oh.
I thought 6:30 was your max. What's 6:30 is my max? His max. Oh, okay. Anyways, well, that's better. Yeah. So this is like, yeah, no, it's pretty cool. So I can, I really like this thing because what it allows me to do when I record all my TikToks, I can now have this thing like go through a script. It can also show like the chat. You can even put Zoom. You can put screens on this. You can put Zoom stuff on it. It's super cool. I wanted this for a while, and it's been like sold out for a while, and but I guess it got back in stock. So yeah, it's super cool. They got some. Yeah, they got some six. It was kind of a pain to set it up, and honestly, the webcam quality that I'm using on this one isn't the best. I need to get a what is that? I need to get like a DSLR or something for this, really. But that's gonna cost me like another $500 or $600. That eye contact gonna be on point. It's like, yeah, but also like kind of creepy, right? If I'm just like staring at you like this all the time. I'll have to go back and watch to see how it is. But yeah, because we're not used to like direct eye contact, right? It's kind of weird online. I don't know. We'll see.
Well, don't you use glasses? Do you use glasses or not?
No, dude, I got LASIK. 2 years ago. I used to have LASIK's where they like laser your eyes, dude.
Does it actually work?
No, it does. Yeah, no, for sure. I wore glasses all my life.
Isn't there two ways? There's
yeah, there's PRK or LASIK.
really?
Yeah.
Yeah. Isn't LASIK the one where they cut open your pupil?
Yeah, both of them they have to make a cut. Well, actually, I don't think PRK they make a cut, but
No, I think they do some different way, but you gotta spend like a week or two blind. I think we talked
yeah, no,
about
yeah,
it before.
PRK you can't see for a week or two. LASIK you can see like 40 minutes later. So I was
How
like,
risky is it?
I don't think it's that risky, honestly. I mean, it took like a month or two to recover, which was like kind of weird because
Wait.
like at night like things would look like kind of weird, but yeah.
So is it like literally like a factory reset? That's all.
Yeah.
Just complete, like you're just born like new eyes completely.
Yeah, like you can see again. It's super dope.
There's no like side effects, like.
I mean, you get dry eyes for like first couple weeks or something, but yeah, no, LASIK is dope. Yeah, what's up? There you are, Turtle, dude. Oh wow, he's got the glass. 1 sec. Let me get you on the big screen. Sorry, 1 sec. I gotta move you over. 1 sec. There we go. There you go. There you are, dude. What's up, Turtle? There you go. What's up? Yeah, see, yeah, he's got the glasses. See, I used to wear glasses. I used to wear these glasses all the time, dude. Yeah. But
Or else I'm hella blind.
I know I'm hella blind too, dude. I was like minus 3.5, I think is what I was. Minus 3.75. Yeah. He's got the vape pen. If you get it done at like a nice place, it's like $6,000, 7 or 8. I got it done at UCLA, and they only charged me $2. It was nice. Yeah.
Why only 2?
Because they had a resident do it. So this is like a med student or something. Here, I'll show you like what they do. They literally do this.
They were like scared.
Here, no, I'll show you. Like they literally have to cut into your. They do this. They literally like
Go blind.
cut into your eye and stuff. But it's cool. Like they don't, man. It's a pretty standard procedure, and then everything is controlled by computers. So the computer just like they type in some numbers, and it just does stuff. It is scary, but they give you like Valium, which is a drug that makes you like super like relaxed, and you're chill. Like,
wait, but are you?
I gotta give me some of that.
no, you're awake the whole time. You are awake the whole time. Yeah, I was awake the whole time.
I could not do that.
No, because you have to stare at a light. So you have yeah. So they have like a light thing, and you have to stare at it, and then that is what aligns it so that the laser can hit the right parts of your eye. Yeah.
I got Asian eyes.
You got Asian eyes? Yeah, you got the Latino eyes, dude. You got the Latino eyes. He's got the Latino eyes, dude. They're not Asian. How often do you have to get LASIK? Once. You get it once, and then it's good for, I want to say, until I'm probably 40 or 50, is what I would say.
Wait, so how much years? Like 10, 15?
Yeah, 10, 15 years for me. Yeah, I'm probably good.
Wait, so it's not forever, though?
No, bro, because like eventually you get old, dude, and when you get old, like it doesn't matter. You just can't see shit. You have to have glasses. That's called that. That's
a normal process, though.
Yeah, that's like reading glasses. Like your parents will eventually need glasses. They always do. It just happens. It's just what happens as you get older.
Yeah, both my parents need glasses.
Exactly. Yeah. So yeah. What was it? Equity was asking, what's the difference between PRK? They're both the same risk, but as Ramiro was saying, so PRK you can't see for like 2 weeks. Like it's like it's very it's blurry,
that's usually
right?
when you get into the Air Force. If you want to join the Air Force,
You do.
that's what you that's usually what you would get.
Yeah,
because
you would get
for,
PRK because there's not a slit. There's no slit in PRK. I think
Yeah.
there's no flap.
For LASIK, they slit your pupil
Mhm.
to put the light and heal your glasses. I mean, heal your eyes. But the risk with that is if you're in airports, you're gonna be in high
In
speed
high G environments. Yeah, no, that's very smart. Yeah, exactly,
Yeah.
Ramiro. Yeah. So yeah, because like when you're doing these things on the in the jets and the fighter jets, and it's like it's very high G, it can rip the flap open accidentally if you're still there.
Mm-hmm.
Why can't you see for 2 weeks,
it
but you
never
can
really
for
feels-
LASIK? Yeah, here I'll show you the reason why. It's actually kind of cool. I should get an ophthalmologist up here, and like he should be on like the AMA sometime, so we could like do that.
On God, yes.
Oh God, wouldn't that be cool? But yeah, this is the reason. So with PRK, well, I'm trying to see here, but I think they just like they blast your cornea is what they do. With LASIK, they pull the flap back, they blast your cornea, and then they put it back. So with PRK, you need your cornea to heal, which takes a lot longer. With LASIK, because they peel back, I think, enough of the eye, they don't have to laser it as much to correct it. So it's faster with the healing is what it is. Yeah. So LASIK, I could see like pretty much the next day, which was great because I couldn't take like a whole day
Okay.
off. What's up, Teacup?
To be truthful, PRK would be the best thing to get when you're younger. Because the older you are, it's hard. It's gonna be harder to be able to not see for 2 weeks. When you're younger,
Yeah.
you're not really doing too much responsibility, so you're able to at least have 2 weeks break, especially during summer. No,
Yeah, no,
school,
no, no.
responsibilities, nothing.
Yeah, you're exactly right, Ramiro. Yeah, that's a again, like I still had to teach, I still had to pay rent, I still had to do things. So like I couldn't take 2 weeks off. But if you're kids, yeah, you could take 2 weeks off. It's like summer vacation or something. You're fine, right? Yeah.
Mm-hmm.
Yeah, that's smart, Ramiro. That's really smart. Nice. Okay. Here, let me start off doing some questions. We got some questions on the streams. I know I missed you guys for like 2 weeks, so let me get to doing some questions for you guys. All right. All right, where we are. Cool. Thanks, Eternal Dude. All right, welcome everyone. Office Hours. My name is Dr. Gold's Actual Education. The stream that helps you out with math, homework, science, homework. Lots of fun stuff. I had a fun time talking to you guys. Yeah, sorry, I was out for the last 2 weeks with not last 2 weeks. Sorry, I was out for the last 2 streams. Sorry, because we missed the AMA on Friday and I missed Monday because I was performing in Houston. I had to DJ an event. It was a lot of fun. But I'm glad to be back here. I'm gonna mute the stream. All right, cool. Good to see you, Teacup. Teacup, what's this? I put some Russian math questions. I need help. Yes, awesome. Yeah, okay, cool. Yeah, let's do it. We'll do a bunch of questions. I have a full stream today. I don't have to go for another. I don't have to teach for another 4 hours. So I got all you guys for today. Who did I help out with? Okay, G Monet, you're first here. You got the first screenshot. I hate Russian school math so much. I did it once. It was horrible. Yeah, Jamarcus isn't having the best time with it, man. Yeah, he's not. I also put one for my kangaroo practice. Oh, that's too funny that you both did the Russian school of math. Yeah. Okay, let's see. All right, here's a question. Armene says, in a team... Ooh, chess. We do like chess. Chess is fun. I'm a big fan of chess. Each team consists of 3 players, and each player plays exactly once against every player from all the other... Okay, whoa. Okay, so each team... Oh, where's it? No. One sec. I need this over. Okay. Okay, so we have each team has 3 players. And each player plays exactly once against every player from all the other teams. Okay, so it's like a round robin or something. Okay, cool. For organizational regions, no more than 250 games can be played in total. At most, how many teams can enter from the tournament? Okay. Yeah, this is a cool question. I like this one actually. This is interesting. Okay. Let's try to develop a model for if there were just 2 teams. And then if we start seeing a pattern, then you will see it's something with like factorials or something. Some homie sticks a knife to me, it's odd, yeah. Okay, so let's say there were just 2 teams, okay? So we had team 1 and we had team 2, okay? And then this had 3 people. So each player has to play exactly once against every player from every other team. Okay. So this means, and let's say we have like A, B, C, and like D, E, F, right? So you'd have to have AD, you'd have to have AE, and you'd have to have AF play, okay? And then you'd have to have BD and BF play. Yeah, and BE. Sorry. You have to have BD, BE, and BF play, and then you have to have CD, CE, and CF play. Yeah. Okay. And then the cool thing here is I think everyone's D's already played with A, B's already played with D, and D's already played with C. So we've already solved that team 2 has to also like play with everyone as well. Okay. So and how many games was this? This was 9. Okay. Cool. All right, what happens if we add another team though? So there's gonna be 9 games between team 1 and this team, but then team 1 and team 2 have to play, and then team 3 and team 2 have to play each other. Oh, interesting. Okay, so you end up getting 9 from here, another 9 from here, and then another 9 games from here, I believe. No, it's okay. You're not stupid. It's okay. Basically, every time you add a team, right? Now this team has to play. I'm starting to see a pattern here. It's there's some sort of there's a pattern forming. Because then look at team 4. Team 1 would have to do 9, 9, 9. But then team 2 would have to do 9 and 9 with here, right? And then team 3 would have to do 9 and 9 with here. And then team 4's already played with everyone. Oh, okay. So I think it's the number of teams, right? So let's see. Let's call this like n is the number of teams. So so we have n minus 1 times 3. That's what happens. No, times 9. Sorry, because each team they play with is 9 games. Because you have to do, this guy has to play with all these people. This guy has to play with all these people. This guy has to play with all these people. Yeah, 3. Yeah, exactly. Yeah. Okay. Well, we want to do number of teams. Okay, so it's n minus 1 times 9. That's for that to happen. But then it's there's a factorial here happening. Do you see this? Because then this team has to play with 2 teams, right? And then so it's plus n minus 2, right, times 9, and then it's plus n minus 3 times 9. Okay. I think I'm starting to see a pattern here, right? Because then this has to play with just in this case there are 4 teams, so they play with 3 times 3. They play with 2 times 3, okay, and then he plays with 1 times 9. Times 9 times 9. Okay, that's what it is, and that's for n is equal to 4. Right, G-min A, we get that? Okay. So if it was n minus 5, if it was n equals 5, right, this is n minus 1 times 9 plus n minus 2 times 9 plus n minus 3 times 9. So this goes all the way to n minus... Oh, this goes all the way to just 1 times 9 is what it is. So it goes from n minus 1 to 1. Yeah, which is n minus 1. Yeah, just goes 1. My stomach is imploding right now, but I don't know. Am I cancer? Don't go looking up on WebMD. Yeah, don't do it. Don't do it. Every time you'll just see you have cancer. Man, I wish I could express this. This looks like a factorial, dude. It so does. Because the problem is factorials are multiplicative, right? So if I have like 5 factorial, that's 5 times 4 times 3 times 2. And by the same token, right, n factorial is equal to n times n minus 1 times n minus 2 all the way to 1. Which almost looks like this. This is almost what's happening. But the plussing is messing with it. Isn't this the sum of an arithmetic sequence? Is it? With difference of 8. Oh, I like this. Yes. Oh, you're very smart here, Jamarcus. Yes. So Jamarcus is smart here. So he's realizing that this is like going backwards from 1 times 9 plus 2 times 9 plus 3 times 9, right? All the way up to n minus 1 times 9. Yeah. Good job, Jamarcus. Yeah, that's smart. Yeah, so I was looking at it backwards this way, but you can also look at it the other direction, and this is an arithmetic sequence is what this is. Because we're just, the difference is 9. Yeah. 9, 18, 27, blah, 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 all the way to n minus 1. Very cool. Okay, so then what again is the sum of an arithmetic sequence? I think it's the first term plus the last term divided by 2 times n. Is that what it is, right? Is it a1 plus a sub n divided by 2 times n? I think that's what it is. Yeah, we'll look it up real quick. Well, no, I don't like this one. Arithmetic sum. Yeah, it's this. Wait, can't you get a quadratic? He says. Wait, one sec here. Sorry. Why do you say it's a quadratic? Sorry. Yeah, I'm looking at GminA. Give me a second. So 3n times n minus 1. You have n number of teams. 3n equals the number of players. The same team doesn't play itself. Okay, 3n is the number of games. Wait, I'm sorry. Yeah, you're typing so many things that, like, yeah, I'm confused too what you're doing. Okay, give me a second. I think Jamarcus has the right idea here, okay? Which is just yeah, this just has to be equal to 250 basically, right? Let's just figure out what it's going to be, all right? So the first term is always just going to be 9, right? That's always going to be the first term, which is okay. All right? And then this is what we're solving for. We're solving for what the nth term is going to be given this. But okay, but the nth term, right, is it's wait, the nth term is n times 9, right? Right, if we have two, yes, okay. So this is 9n. This is almost going to be a quadratic. I think it is, honestly. You're close, man. Okay. So 500 is equal to 9n plus 9n squared. Okay, now this is a quadratic that we have to solve. So 9n squared plus 9n minus 500 has to be equal to 0. I'm going to use Wolfram for this one. So 9n plus 9n squared. Why did it autocomplete that? Sorry. Plus 9n minus 500 equal to 0. Yeah, Wolfram has saved my life so many times, dude. Okay. So, okay, what's this real root? What is this equal to? What's the root? Can I just get like an approximate? Let me just give me an approximate form. Okay. So 6.9. So I think 6 is the maximum value for n. Right? That's what that tells me. That tells me that, so if n is equal to 6.9, we're really only allowing n to equal to 6, okay? But remember that goes up to n minus 1 number of teams. So that really means 7 teams. Let's see if that's right. Was 7 even an answer choice? Yeah, I think it's 7. Is the answer 7? Oh, the answer is 7? Oh, fuck yeah, dude.
That's dope.
That's cool.
Well done. Well
Smart man for real. Yeah, I mean, I had some help. Jamarcus really helped me on that one, Jamarcus. Yeah, I appreciate that, dude. That was a good call. I didn't notice that us going this way in a sequence was the same as like an arithmetic sequence going the other direction. Jamarcus W's man. Yeah, good job, dude. Good job, Jamarcus. I'm gonna give you a point anyways, Jamarcus, because like you really saved that one. But then also G-Mane gets one too. Good job, G-Mane. I'm eating Oreo for my stomach. Maybe it'll help. Oh no, dude. What are you doing? Where's my no?
No.
Yeah, don't eat. Please don't eat too many Oreos, man. Dude, what? Scientific experiment. Oh, I bet it is. Okay. 1 Oreo, 1 scientific experiment. Okay, cool. Okay, let's see what the next question is. Who we got? I got Obama. Let's see if Obama wants to come up and get some help. Where's at Obama? Obama. You have swimming 45 minutes? Cool, dude. Equity's here too. It's good to see Equity. Yeah, nice. Nice. Yeah, I'm seeing what I need to do with this thing. I need to get a better camera, and then I also need it to not be attached to my desk. Because if I do this and like hit my desk, like I just like vibrate like crazy. So I need it independent of my desk. That's okay. I can figure out what that's gonna be at some point. What's up, Obama?
Yo.
Good to see you, dude. Cuber, why are you so tired, dude? What's wrong? Why is Cuber so tired? Cuber was in DC, I know. All right, let's do your question, dude. Obama, let's do it. Okay. Ooh, we're doing angle, side, dude. This is cool.
Yeah, I don't get all that stuff. I don't get the ASA or SSS, whatever that is.
Yeah, so I mean, okay, one second. I got too much shit on my fucking desk, dude. Ugh, move. I need a bigger desk. Okay, all right. So these things, is saying that like if you have an angle, and then a side, and it has to do with like the ordering of it. Okay. So let's look at like a triangle, for instance. Let's just say we had some triangle that looked like this. Okay. Let's say this was an angle. Let's say this was like, I don't know, like 37 degrees. This was a length of 12, and this is 90 degrees, okay? This is an example, Obama, of having angle, side, angle. You see how we went we went in this direction, and we have angle, side, angle?
The degrees angle, right?
The degrees are angles. Yes, exactly. Okay.
Okay.
I could also have side angle, okay? Let's say, for instance, I had 5, 12, and 13. This is an example of side angle.
All right.
Okay, it's just like the ordering and stuff. I mean, these are mainly used for proving like that, proving that like triangles are congruent and whatnot. I think if you can show that the angle side angle of one triangle is equal to the angle side angle of another triangle, that the triangles are the same. But we're not doing that. You're just trying to figure out like what the missing sides are, right?
Yeah.
Okay. So, I mean, who gives a fuck if it's this? I mean, whatever. It does kind of matter, because I think what's going to happen is you're right. You're either G-Mane, you're going to either use law of sines or law of cosines. Okay. And here's like do you know what the law of sines and law of cosines are?
We've only learned sine.
Okay. So if you sorry. You know what, let me just get a picture of it. It'll be much easier to just get a picture. Law of sines, law of cosines. You probably do need to use inverse for something, but here we go. Yes. Whatever. Law of sines ambiguous case, dude. What? What? Why do they tell this to you? Okay. All right. Here's what happens. If you have a pair, so always what you want to be looking at, Obama, is like, what do I have, right? And what am I trying to figure out? Okay. So
Yeah.
if I have two angles and I have a side and I'm looking for another side. Oh, yo, what's up, Don? Appreciate it, Don. My boy Don was doing some matrix math earlier. Yeah, dude. Yeah, shout out to Don, dude. Don's great, dude. Shout out Don. Don does math. Nice. Thanks, Don. So if and also when we say like sides and angles, we mean like in this case this is the angle and then this is the side that corresponds to it because it's opposite of it. Okay? Does that make sense?
Okay. Yeah.
Okay. So if I have an angle and a side, and let's say I have another angle but I'm missing this side, that's a case to use the law of sines, okay? Law of sines is for like two sides, two angles. Some combination of you have them and you're looking for one of them. That's how it goes. The matrix math used up all my mental math ability. Dude, I agree, dude. Dude, you were doing some insane head stuff with matrix. Dude, I can't, dude. I'm just like, no. I get my rows and columns mixed up already, so it's already a bad news bears for me, dude. Okay, that's law of sines. And then there is the law of cosines. Law of cosines is pretty cool. Let's find a picture for that. That's what well, this is the full picture I really wanted. Andy Math, why didn't you just post this to me? Okay, here we go. Wait, 1 second. There we go. This is what I want to see. Okay. So what the law of cosines does is you need three sides and one angle. Okay? Do you see how in both cases you need four things? You either you need four things and are looking for four things. It's just different combinations of it. So law of cosines is you only need one angle or you only need to be looking for one angle. And that's why they say here. Do you see how this is SAS, SSS, right? This, I guess, they're saying like what you have here. So if you have three sides, right, you can figure out the last angle using law of cosines. If you have two sides and one angle, then you can figure out the last. You can figure out the last side using law of cosines as well. I don't think you can figure out. You can't figure out the next. You can't figure out the other angle though. You can't do that. Yeah. Anyways, okay. But this is kind of like garbage. Like I wouldn't use this to like figure out which one. Just look at the picture and you'll see it, man. So, like, let's look for instance at this one. First of all, okay, they're asking you to find BC. Okay, this is BC. All right, and look at all the other information that they give me, Obama here. What other information do they give me here?
Well, like the degrees and sides?
Good, yeah. Okay, so do you see how they give me one of these and they give me one of these? Okay.
Yeah.
So that's two angles already, right? And then let's look, right? They give me one of the sides. Again, and we got to make sure it's a corresponding side. So they give me a side here. And then they're asking me to figure out this one, which is another side, okay? So this is a case of where, right, what I have and what I'm looking for includes two angles and two sides. Which one of these laws do we use for two angles and two sides?
Law of sines?
Yes. Yeah, we use this one, right? Okay. So, let me just delete this page for you. Okay. All right. Here, let's put this all the way over here. Okay. So, what I'm going to do is I'm going to set up my equation, which is, right, sine of A over A is equal to sine. In this case, we're going to say sine of C over C, because I see that this is angle C. Do you understand this so far?
Yeah.
Good. Okay. So this is going to be sine of what? What is angle A?
57?
57, right? Good. So I have sine of 57 all over my missing side right here, A. We're trying to figure out BC, okay. And that's equal to sine of what?
34.
Good. Sine of 34 over
14?
14, yes. Yes. Good. Okay. Now we have our equation, right? This isn't too bad. Do you know how to like solve this? This requires like a little bit of algebra to do.
Aren't you gonna isolate A?
We are going to isolate A. Yeah. And this is actually why I like the law of signs. Yeah, your chats are working. I can see you, dude. What's up, TT? Why I like the law of signs, right, is that you're always going to have just like two fractions next to each other, which means you can do that butterfly method stuff. Do you remember this? Remember, like, you can do this if you really want?
Yeah.
Yeah. The other cool thing is you can always just interchange sides, right? I can always just take this and put it up here, and then I can take, you know, this and put it up here. I can do whatever with the diagonals. The diagonals you can move around and combine as much as you want, okay? So when I have sine of 57 over A is equal to sine of 34 over 14, the other trick I can do is if I flip one side, I can just flip the other side as well. It's very easy. Do you see how like A's on the bottom? We don't like A on the bottom.
You can literally flip it like A over sine 57.
Yes, bro. This is just A over sine of 57, but you got to flip the other one as well. Is 14 over sine of 34. Do you see how you
multiply sine 57?
Good. Yes.
On both sides.
Yes. Yeah. Now you can just take this. You can just take this, right, and you just put it up here.
You have to do anything else or just calculator?
You're just done. You're done at this point. Yeah. Yeah. So if you wanted, right, you just pull out the our handy dandy calculator here. Where'd she go? Okay, there she is. Yeah. You just do 14 sine of 57, and then you divide it by sine of 34. And that gets you an answer 21, basically. Sounds about right. So, yeah, we'd say that this one's 21.
All right.
That makes sense, yeah?
Yeah.
Okay, let's do the next one. Well, let me see one that's, like, different. Okay. So...
I don't get what they mean when there's only one thingy where it doesn't... You know how the top ones say find, like, A, B, or B, C? What does the D mean?
What does what mean, sorry?
D, like number D. What does it mean? Find the measurement of like.
Oh, this is angle. This means angle. Yeah, I know.
Okay.
This thing right here, bro. This means angle.
So just okay.
Yeah, they want to find the measure of angle B. So first of all, okay, I'm not going to redo these ones but you can see it. But you see out here, right? I have side, angle, and I have angle, side.
Mm-hmm.
It's going to be the same law of sines, right? Because see, angle, side. Angle side. Same shit. It's the same shit as this one. See how we had angle side, angle side?
Yeah.
Good. That's easy. This says find AC. It's the same question, right? So look, this is a side, right? Angle side. Oh, it's actually, this one's actually a little tricky. Oh, I see why this one's tricky. Okay. Because you have the angle, and this is the side you're looking for, right? But look, the angle and the side they gave you here, these are not corresponding. This one corresponds to this angle, and this one corresponds to this side. Both things which are not given to you.
Yeah.
Okay. So, in this case, if you wanted to use the law of sines, I would like to know what this angle is, because then I have a side and an angle, and then I have an angle and a side that I'm looking for. Do you know how to find this angle?
Yeah, 180 minus 115 minus 27.
Good. Yeah. Easy. Done. Nice.
Perfect.
Okay. That's easy. And then that's all you do. And then you just do law of sines again. Easy. Right? Okay.
Damn.
This one's tricky. This one's tricky. Okay. Because look. Or actually, dude, this one's also... Dude, none of this is law of cosines, dude. What? This is all just law of sines.
Yeah, because we're just learning sines. We just learned this, like, yesterday, bro.
Oh, okay, okay. Well, then this is the same. Okay, so look.
I'm pretty sure next week we're probably going to get to that.
You're going to get to law of cosines next, yeah. But it's the same thing.
Hopefully.
See, look. Side, angle, right? Angle I'm looking for, and then the side. So how would I do this one? How would I write this one out?
Sine... No, just sine B, right? Sine
Good,
B?
sine B. Yeah, that's good.
Nice.
Over
Sine.
5.
Over 5 is equal to...
Then sine 113
Good.
over 11.
Over 11, good. Nice. All right.
Do you
Next.
like the cross multiplying thing, whatever it's called?
You can do the cross multiplying, but like remember our easy trick here, right? I can just take this and just put it up here. So now I just have that sine b is equal to this. Okay. You can always just move things around the diagonals all the way around, yeah. So now I have sine of b is equal to what this is, which, yeah, you need a calculator for this, right? So this is 5 sine 113, which equals that, divided by 11, okay. So that's 0.4184. Do you know what the next step to do here is?
No.
How do I get b, dude, when I have a sine b attached to it? Oh, good to see you, Jermaine.
Oh, you do inverse like the -1, I think. Is that what you do?
Yes. You do this. You do the inverse sign on both sides. Cool.
Yeah.
See how this goes away? Or there you go. That's what I wanted. Yeah. So it goes away. So now I have just b is equal to sine inverse of this, which you can just do here. You just do sine inverse of what that number was on the calculator like this. And that gets you 24.7 degrees. And you're done. Nice.
Thank you.
You're very welcome, dude. Hopefully it makes more sense here. I'll send you the PDF of it. Or the PNG.
Yeah. I mean, we have
Yeah.
a quiz on these stuff every week.
Well,
Kind of annoying.
do the practice ones here, man. You'll be good. Nice.
Yeah. I mean, I always try to keep doing my homework until I actually fully understand it.
Nice. Yeah. Because, yeah, again, and this stuff in math, man, dude, like, you'll learn it now, but you're going to use it again and again and again and again. And so it never ends, dog. So
I mean,
it's,
I saw you were a college student. You guys were using like cotangent stuff like that. I remember. It was like a week ago, I think.
yeah, we were using
down.
arc cotangent. Yeah. You use all this trig stuff like over and over and over again. Once you get to even like calculus and stuff, dude, it just does not stop.
Is arc cotangent just -1? I thought it was just that.
No, so arc cotangent is the inverse of cotangent. That's all it is. It's weird because like cotangent is tangent flipped, but then arc cotangent is the inverse of the flip. And so this is where like you have like too many of these -1s that start messing with you, right? Here, I'll show you what I'm talking about, right? Okay, tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. So what you kind of see here is that cotangent is equal to 1 over tangent, which is like tangent to the -1, but it's different than arc tangent.
Oh.
Yeah, because then we have what's called like arc cotangent, and that's this.
Yeah,
It's different.
That's what I thought.
They're different things. They're different things. So what this does is this does something of a number, and it gives you an angle.
Okay.
Whereas this does something, of an angle, and it'll give you a number or a ratio is what we say. Yeah.
So weren't we like just doing that, but with like sine or something?
We were doing this. We were doing this stuff. Yeah, exactly. Yeah. This we weren't. This is different. Yeah. Different.
Yeah.
Okay. Cool. Nice. Yeah. Always feel free to ask about like, more like what's going on here because like there's a whole process to it,
Yeah.
Cool. All right. Good job, Obama. Nice. Let's see what we got next. Equity. What's up, Equity? What are we doing? Why's my phone blowing up? People need to chill. People doing on my phone. Okay. All right. Let's do it. Here, one second. Move this over. Okay. Ooh, this looks like... What are we doing here? Exponentials. I like exponentials. Cool. Jamarcus, did we talk about Mr. Ravioli? Yeah, Mr. Ravioli, dude. Mr. Ravioli's fun. Okay, it's uploading. Yeah, anyone else who just found us here through Twitch and whatnot, we have a lot of other really fun math streamer friends. If you want to go follow them, there's all their links. please check them out. They're really dope. And they do similar stuff that we do. You know, we help students out. I mainly help out middle school, high school, like early college. I know, Zach, E to the Pi I, Penn Center, and yeah, even Dawn today was doing like linear algebra stuff. So if the higher level math stuff, those guys are really good at doing. So hit them up. Some of this may seem like boring to you guys, but it's because I teach a lot of fundamental stuff to middle school and high school kids. But it's also like, you know, if you're coming back to math because, you know, you've been out of it for a bit. I have a lot of adult learners who, you know, haven't done math in years, and this is a great review for them to get back into it. Gold, is the Elgato your new webcam? So this one is the Elgato. But then the one that pops up here, that's my Brio. I need to switch because the quality on the Elgato is worse because I'm using a C920. The main thing the Elgato is it has the it's the prompter. It has it so like I can see the chat and speak to it at the same time. It's cool. I don't know how I'll see how much I want to use it on streams. But yeah, because the quality on this one is definitely worse because it's a 920, not a Brio. But I really need to get a what do I need to get? I need to get like a DSLR for it. That's a real thing I gotta do. Next on the wish list, if anyone wants to buy me more equipment. Yeah, the quality looks much worse. I agree. It does. Yeah. I need a better webcam for the prompter. I'm just using what I have so far. All good. Yeah, it's actually cool. Actually, I can switch that. Watch this. Here, I'll switch it. It's kind of cool. If we go to just chatting, and then I'm gonna turn on. So there's double gold. There we go. That's me as well. So we have that one as well. I have a lot of webcams. We'll use this for now. Yes, that would be a DSLR. That would be a nice DSLR to use. I'm trying to think what most of the streamers use. Yeah, if you wanted the webcams I'm using right now, just for anyone else who's streaming and just curious. So I have the one that's being broadcasted right now. That's the Logitech Brio, which is it's a very good webcam. It's this one. Kind of expensive. This one's like 170. And then the other one I was just using is called the C920, which is like $70. Yeah. So this is kind of a staple. It's not as nice as the Brio, but yeah, in reality, if I really want to do stuff with that, I need like a DSLR, which there are a couple options for that. But yeah, that's generally around $500 or something. Or I guess, I mean, I think Elgato really wants you to use their, I think they want you to use their Webcam Pro or something. Yeah. Oh, Jesus, this thing's $300, dude. What?
No.
Get out, dude. What? Who the hell's gonna pay $300 for a webcam? Dude, you can get a nice camera for this, dude. What? Yo, what's up, monkey? Yeah, I don't know if I would pay this much for this. This seems like a lot of money. Okay. Yeah, yeah, whatever. That's a lot. Anyways. You're not late, monkey. It's okay, dude. You're here. Important thing is you're here. All right, let's do this one. Let's do okay. So write an exponential equation in the form a to the bx that models the graph below. This is a really good one to do. All right. Oh, they say first differences and then ratio of the first differences. Oh, okay. So when doing this one, Equity, I believe you want to like figure out like what some points would be first, right? So I usually look for like where things intersect really nicely on the line here. So I look here at like x equals 0, and that looks like y equals 2. So let's just put that there, okay? And then at 1, it looks like we have 6, okay? And then at 2, it looks like we have 18. Probably. Okay, so then the first differences, I guess. So they want to say that, what, this difference is 4. This difference is 12. So what, the ratio of the first differences is 3? Yeah. So yeah, base value, B, so that's like how much it's multiplying by each time. So this is multiplying by 3. This is multiplying by 3. So yeah, in this case, B is probably equal to 3. And then they say find A by substituting 0, 2 into this equation. So when x is equal to 0, you're going to get A. Oh, let's use a different color. You're going to get A times B to the 0. Anything to the 0 power is just 1. This goes away to 1. All right. So if we know this is equal to 2, that's what 0, 2 means, equity. It means x is equal to 0, y is equal to 2. That tells me right away that just A is equal to 2. So, yeah, then you get it here. It's just 2 times 3 to the third. And if you wanted to test this, you can or 2 times 3 to the x, sorry. Not 3 to the third. My bad. You can put in some point. We already tested that this one works, but look, when x equals to 1, right? That's 3 to the 1, which is just 3 times 2, which is just 6. When x is equal to 2, it's 3 to the second, which is 9 times 2, 18. So yeah, this one works. And then yeah, this is just your answer. Not too hard, equity. I think it was pretty good, yeah. Nice. You're welcome, dude.
Well done. Well done.
Easier question today, which is good. We like easy questions. Yeah. Let's talk about Taco Cat. Ooh, I like this. This is a cool one. I'm talking about exponential decay. Taco, you here, dude? Wait for you, Taco, dude. I was gonna go help Cuber out. Or Ethan, Jamarcus. Oh, and we got Josue. Oh, are you here? Here, yeah? You here? Yeah? Alright, here, let's do this one, Taco. Oh, shoot. Oh, shoot, he says. What's up, Ethan?
Hello. Hey,
Good to see you. Good to see you too, Ethan. Yeah, we'll go through everyone's. We got it.
Yeah, if Dr. God doesn't show up, then I can do it.
I think he's here. I think I saw him in the chat. Yeah, I saw you. Yeah, I saw you, Taco. You're good.
Yes?
Yeah, he's here.
I see him.
Okay. So it says a certain drug decays at a rate of 15% per hour if the initial dose is 500 milligrams and it is not safe to drive. Oh no. What is this? What's this drug? Why am I hearing a ton of static, dude? What the hell's happening here? No, it's not you, dude. What the hell? What are we hearing that from? One sec, Ethan. I feel like that. One sec. Let me remove you from the stage real quick. No, that didn't fix it. What the hell? Give me a second, Taco. I'm just hearing like a ton of Discord's bugging. Disconnect. Oh wow, yeah. Discord just decided to break. Okay, well, give me a second. Give me 1 second here. Okay, 1 second. 1 second. 1 sec, boys. Okay, there we go. All right. Now let me speak on the stage. Okay, we're back. Okay, now let me share my screen. Yeah, for some reason, like the static from Ethan was sticking on my Discord. You see, Discord like is putting ads in now. Someone was saying you had like open boxes or something. Like there's a new store. I don't know what's going on. Like I leave Discord for like 4 days, dude, and like they start changing everything. Yeah, dude. I'm 1 sec. I'm pretty sure Discord has ads. Discord ads. Yeah. Yeah, Discord's gonna start putting ads and things. A little confused what they're doing here, but oh, yeah, I don't know. Not ads, man. Yeah, not the ads, dude. Come on, Discord. Don't do us dirty like that, man. I know. Anyways, okay. Okay, 15% per hour. If the initial dose. Oh, the loot. Oh, it was loot boxes. That's what it was, Dawn. Oh, that's what people were talking about. Yeah, someone was saying like, how many boxes do you have to open or something? Yeah, I was still flying yesterday, so I didn't really see anything. But yeah, no, the ads are real. Yeah, they're gonna. Yeah, I hope they don't, man, because I really love Discord. Like, it's a great platform. I really it is. I do think it is, but like anything, it starts going to shit once they start running ads on it. We'll see. Okay. It's not safe to drive until there's 50 milligrams left in a person's system. How long will it be until it is safe for someone to drive? Okay, this is cool. Yeah, this is exponential decay. So here, let's get rid of this so that you don't see stuff. Okay. So yeah, exponential decay works like this. So the amount in something, right, is equal to the principal amount, okay, times what we say is like the rate of decay, or 1 minus the rate of decay, and then this is going to be to the t. And then this rate of decay is like per whatever. So here, we want the amount that's still left in the person's system, Taco, to be how much? We want them to be, we want it to be safe for them to drive. So, like, how much do we want it to be? This is a very interesting question, honestly. Like, especially for a kid. You're just like, what? You took too much ibuprofen, can't drive? This amount, Taco, you want this to be 50. You want there to be 50. And the amount that starts in the person's system is 500. Again, this isn't a very relatable question for you. Because, like, hopefully y'all kids aren't, like, taking substances and trying to drive. You're a little too young for any of that. And then the decay rate right here is 15%. So that's 1 minus point. Anytime we have percentages and you put these things into equations, guys, you have to put them in as decimals, okay? And then this is going to be to the t. Okay. And then this is what we have to solve for. I do take substances, but I do not drive, so it's still okay. Okay. Yeah, as long as you're not harming anyone, I'm fine. Yeah. Okay. So we can move this over. So this is 50 over 500 is equal to 0.85 to the t, okay? 50 over 500, this is kind of cool. We can start canceling some zeros out, right? This goes away. Now we're left with 5 over 50, which is the same thing as just 1 over 10, which is just equal to 0.1, okay? So we're going to have 0.1 is equal to 0.85 all to the t. Okay? There are a trivial amount of fatalities caused. Yeah, I guess so. Do you know how to solve for this, by the way, Taco? Do you know how to get this thing down? How do we solve for t when t's an exponent? Right? You don't know. Yeah, it's okay. Like, if t was here, right? How would I solve for t if t was just being multiplied? What would I do to get t by itself? Oh, not exactly square. You would just divide this by 0.85, right? That would go away. This would be really nice. Super easy to do. Unfortunately, life is not that easy for us because this is up here in the exponent, okay? Whenever you have variables that are up in the exponent that you're trying to solve here, yeah, oh, that's it. Okay, you square stuff if there's a exponent that's a number. In this case, the exponent is a variable, and we're trying to get the variable by itself. This is a time for you to log both sides. We use logarithms for this, okay? Yes. The key thing about logarithms, if I ever have like the log of a to the b, this b here comes out front, and it just becomes b log a. So when I take the log of something to the t, that's the same, that t is just going to come down over here as well. Taco says, another word that I don't know what it means. Yeah, I know. It's okay. It's okay. Yeah, logarithm is I can go into logarithms later, but for right now, just think of it as an algebra tool, and we can explain what logarithms are on another lesson. Okay, because yeah, this is b log a. So what that did when we took the log of both sides is that took my t and it brought it down, which is really nice. Okay, because now if I'm just solving for t here, so really what's happening here, let's move this over. No, I'm gonna move this over here and move this over. Okay, is now we have t being multiplied by all this. Okay, how do I get t by itself here, Taco? Like how do I get this by itself? What do we do with this? These two things are multiplying by each other. Divide. Exactly, Taco. Yeah. So this is going to go over here. Okay. So now this goes over here. We're going to take this. We're going to put it over here. Good. That's what we got so far. So now we just do t is just the log of this divided by the log of this, which you can do with a calculator. So what is that? Log of 0.1 divided by the log of 0.85. Okay. And that's just going to get you 14.17. Okay, so t is equal to 14.17. Okay, so that's the number of hours you would have to wait after taking this drug to be able to drive, which is a very long time. Like 14 hours? Like what? Like most people don't sleep 14 hours. I sleep like 5 or 6. But yeah, that's the answer. Good job. Nice. Add mount 1. Taco cat. All right, let's keep rolling. We got next. Cuber! What's up, Cuber? Cuber, you around? See if Cuber's here. Yeah, you're very welcome, Taco. Yeah, good to see you, dude. I'm not traveling for a lot longer, so yes, I will be here more often. I'm sorry that, yeah, I even last week, I know I was kind of scatterbrained with handling things in the Discord. I really appreciate all the work my mods did when I wasn't here, because, yeah, I was very occupied with this show. Show's done, so I can focus more on Discord. Let's see if Cuber's here. If not, we'll do Ethan's question. Cuber is here. Okay. Cool. Good job, Cuber. Give me 1 sec. Okay. Wait, this is Ethan's. Where's Cuber's? Oh, I like this. We're doing Venn diagrams. You join the call? Hell yeah, dude. I was playing Fortnite. My bad. It's okay. It's okay. Still uploading. What were these loot boxes? Sorry, what were these Discord loot boxes? Did I miss out on them? Can I not do them anymore? What? Loot boxes? Dude, what? Dude, what was this? Oh, that's too funny. It view-botted its own April Fool's video to smash the GTA 6 trailer. That's too funny, what? You're in the call? Alright, cool, let's get you up. Or if you want to speak. You want to speak in the call or you just want to chill in the call? You can do either. Yeah, you can come speak too.
Oh.
What up, dog? Alright, let's see. What are we doing today? Ooh, odd numbers. This is cool. I like this. This is cool. Okay. The diagram shows how Sue sorts some numbers. So, odd numbers are in what looks like this side of the circle, right? And then numbers in the 5 times table are in this end of the circle. Okay. And then these are the ones in between. Okay. So it says, why is 5 in the overlap region of the two circles? That's a good question. Why? Why do you think that is, Cuber?
Because it makes. Because it makes a. It's in the fives table.
It's definitely in the 5s table. Yeah. But it says 5 is in the overlap region, right? Do you see how? Why is my circle thing not drawing? There we go. Okay. Do you see how there's an overlap here? Do you see how this is like?
Yeah.
This means both in a Venn diagram. This means that this satisfies both. So 5, right, is an odd number, right?
Yeah.
But it is also something that is divisible by 5. It's in the 5 times table, right?
Yeah.
Okay, cool. All right. So that's why it's in the region of the 2. Okay, so now they say, let's put 11, 12, 13, 14, 15 in the correct regions. Okay, let's do this. This is cool. All right, where are we going to put 11?
Odd.
Good. What about 12?
On the outside?
Yes, good. Yeah. Put 12 over here, right? Because it's not odd, and it's not divisible by 5. Okay, what about 13?
Odd.
Good. 14?
Outside.
Okay, what about 15?
I'd be in the middle.
Good. Yes, dude. Okay. What about 20? Where would 20 go?
The fives table.
Good. Yeah, that would go here, right? Because that would be divisible by 5, but it's not also odd. Right? Okay, cool.
Yeah.
All right, let's see the second part of your question you had here. Dun dun dun. Let's put it in. Okay. Pete says that when you add two numbers that are multiples of 5, you get a number that is a multiple of 10. Give an example to show that this is sometimes true. Okay. Add two numbers that are multiples of 5, and you get a number that is a multiple of 10. That's kind of cool. What's an example of that being true?
Just 5 and 5.
Sure. Yeah. 5 and 5 are both multiples of 5. Oh wow, that is very big. There we go. Yeah. 5 plus 5 equals 10. Right.
Perfect.
Nice. Okay. Let's show that this is not true always. Let's show an example where this isn't true.
5 plus 10.
Good. Yeah. So 5 plus 10, right? That's equal to 15. 15 is not a multiple of 10, right? But these are both multiples of 5.
Yeah.
Okay, Jane says that when you add two odd numbers, you always get an odd number. So give an example to show this is not. This is cool. We're doing like logic here. You're like proving by like counterexamples and stuff that things are not true.
33 HP plus 33 HP is 66 HP.
There you go. Okay. What has 33 HP, dude? What? Okay, so like, let's explain why two odd numbers always add to make an even number. Okay.
Because when you divide a...
This is actually kind of cool why this works. Don't make me want to give answers from the back of the classroom. You can, Euler, if you want to, man. It's okay.
I'm not sure.
Okay. Well, let's think about it. Do you know how to describe any odd number? Have you seen this before, man? 2n plus 1. Have you seen this?
No.
Okay. This is a way to describe any number that is odd.
I think I know what like it's showing.
Right. Yeah. Well, because look,
Like, any number times like n is like any number.
Good.
Then like you just add 1.
Yeah, exactly. You multiply by 2, then you add 1, right? So if n equals to 3, right? 2 times 3 is equal to 6 plus 1, 7. That gets you an odd number, yeah. So this is a cool thing. You'll learn this in math. This is useful in math when you have to do like sequences, series, and whatnot. But you can describe any odd number as 2 times something else plus 1. Like, give me like any odd number. Like, let's say 37. How could you write 37 as 2n plus 1? What would n be equal to?
75.
No. So if I want this, right, to equal 37, right? Let's say n was equal to 18. Do you see how 2 times 18 plus 1, what is that? What's 2 times 18? Good, it's 37. Yeah. That's 37. Okay. This is what I'm showing to you, Cuber, is that any odd number out there can be just written as 2 times another number plus 1. Okay?
Yeah.
So let's have 2 odd numbers that we add together. So let's do 2n plus 1 plus 2n plus 1. Okay? What would happen if I add these 2 things up? What do we get?
Even?
Well, let's see. So what is 2n plus 2n?
4n.
4n, okay. And then what's 1 plus 1?
2.
2. Okay. So look at this. So this represents like any odd number. This represents like any odd number, okay? And actually I should make these different ends, sorry. Yeah. Let me make this actually a little bit different. Let's say this is 2n plus 1, it represents some odd number, and let's have this be like 2b plus 1. Okay?
Yeah.
Okay, watch what we get. We get 2n plus 2b plus 2. Okay? You see how these combine? We can't combine these because they have different variables. Okay?
Okay.
Do you see how I could factor a 2 out of both of these things?
Yeah.
Okay. This would be 2 times n plus b plus 2. Okay? What is 2 times any number? Is that going to be odd or even?
Even.
Even. And then plus 2, right? Any even number plus 2 is then going to be
Even.
even. Right. So, this is why two odd numbers added together will always just give you an even number.
Okay.
Yeah, it's kind of a cool little explanation. If you wanted to show this to your teacher, this is what I would say. I would say this is like odd number 1. And then this is odd number 2. And you just show that this is always going to be an even number. Okay?
Okay.
Nice. Okay, cool. Good job, dude. Here, I'll send this to you so you can have it.
Well done.
There we go. Cuber. Yeah, it's a cool explanation for that one. Let's. Okay, Ethan, you're next. Let's do it. Then I got Jamarcus and then Josue. Oh, he has to bathe. Okay, that's fine, Ethan. Jamarcus says I'm gonna cry. Okay, which one of these do I want to do? Man, you have so many of them. Okay, let's try it. I'll try to do this one, Jamarcus, for you. Has to do with trapezoids and circles, all types of fun things. Uh-oh. I was still. Oh, I forget you always send me the highest resolution stuff, dude, Jamarcus. Ugh, okay, whatever. Let me just cancel it. No, it's not gonna cancel. It's gonna get mad at me. Yeah, let me cancel this. Okay. Will it even let me upload that? Oh, probably won't. Damn it. One sec. Let me reload this. Okay, there we go. Okay. Wait, where'd the picture go? What the fuck? There we go. Oh my god. Okay, whatever. This is it. Okay. Alrighty, let's see. Okay, the leg AB of the trapezoid ABCD is perpendicular to the base BC. A circle passing through vertices C and okay. Well, let's start drawing some stuff first, real quick here. Okay. Trapezoid. I remember what a trapezoid looks like. I think it's this, right? Okay. A, B, C, D. So we say the leg AB is perpendicular to the base BC. Okay, so this is actually perpendicular then. Sorry, we gotta fix this. Okay, so it's like this. A, B, C, D. Leg is the sides. Oh, leg is the sides? Oh, you're right. It's not the base. Sorry. Okay. My bad. Okay. Well, actually, no. This was okay, right? So one of the legs is perpendicular to one of the bases. Okay. So this is A. Man, dude. What? A, B, C, D. I think this is how we draw it, right? Okay. Cool. All right. A circle passing through vertices C and D is tangent. Wait. A circle passing through vertices is tangent to side A at point E. Oh my god. Why? Why, dude? This is gonna be hard to draw. This is gonna be super hard to draw. Okay, I'm gonna try. Okay. Dude, they really make this a pain in the ass to draw, right? Like, what the hell? Okay, let's do it this way. Okay. Oh, man. Yeah, it's so much easier. I think this is correct, though, right? Is tangent AB at, we're going to say point E. Okay, this is point E. Find the distance from point E to the side CD. Okay, so they want this to this, right? If AD... if AD is equal to 4... Okay, so this is equal to 4... and BC is equal to 3. Okay, well, this is weird. Because we don't have it driven. We do not have this one drawn correctly, right? Oh, man. I need BC to be less. How's this going to work? Ugh. This hurts. Jamarcus, why are you hurting me so much with this question, dude? All right, here. Let's move it. Let's move it. Okay, one sec. I think I need this to come down. I wish, dude, they should give you a diagram, dude. This is rude. They don't give you a diagram. They're making you like come up with this. There we go. This is 4. And then BC is equal to 3. Okay. Cool. I think this is right. Rotate the picture 180. I think it's okay now, right? Yeah. Okay. All right. And find the distance from E to side CD. So we want to figure out this. This is what we're trying to figure out. Question. Okay. I predict there's going to be a lot of triangle theorems in here. Because, yeah, AD is equal to 4. So that's this whole thing, right? But then BC is equal to 3. Okay. Find the distance from point E to the side CD. Okay. Yeah, I agree these are 90. Yeah, that's nice. Yeah, that's cool. I guess, well, the angle at E has to also be 90, right? Yes, AD and BC are parallel, I agree. Oh, okay. Okay. I think this is like a similar trapezoids question, right? Is there something with similar trapezoids? Is there something where, like, I don't know, the ratio of like this to this is the ratio of like this to this or something? I think so. One second. Ooh, Pen Center's live. What's up, Pen? Like, do trapezoids also follow similarity rules? Yeah, angle on a tangent circle. Yeah, I also wanted to deal with that too, maybe. Yeah, but because it's tangent to AB, right? That means it has to also be 90. What's that? The fact that this, yeah, with some triangle stuff, it had to do with like finding this distance and this distance. I think I just want to get this. I think if I get this side and I get this side, we're good. I think we're done. I think that's how this works. Yeah. So how do we get AE and how do we get BE? Given that we only know those two sides, and we don't know any of the AD is 4, BC is 3. I want something with like a radius or something. No. Oh, Oh, wait. I think I can get this. Yeah, let's look. Yeah, this is something to do with, was it? Circle theorems. Yeah, it's all these things, man. No, I need something. Yeah, it's like this. It's like when it's outside of it. That's if it's tangent to 2 points. Do we know that it's tangent at 2 points, though? No. It's only tangent at 1. And even worse, like, A doesn't even hit it. Alternate segment theorem. Okay, what's that? Okay. Yes. Yeah, what does that say? It says the angle that makes is the same as the angle in there. Let's see if that helps us out. But like, what am I making my alternate segments with? You know, what are we gonna do this? Yeah, you want to start? Let's just start drawing some triangles, dude. Maybe let's start doing some things. So that says that. Oh, this hurts my brain, dude. So this is like the triangle, I guess, right? And then we're saying that this angle is equal to this. Good to see you, Ethan, dude. It's equal to this angle, or we say that like this angle is then equal to this angle. Uh-huh. Okay, yeah, maybe I see something here. Let's call this angle equal to B. Let's call this angle equal to A. Because then I kind of see something here, right? Yeah, okay, yeah. Oh man, this is really tricky. This is really tricky, dude. What the hell? Okay. Yeah, so watch this. Let's call this equal to C. Okay. So then that tells me this angle plus this angle, right? So A plus C has to be equal to 90, right? Because this is a right triangle. And then let's call this angle D. So B plus D is also equal to 90. Okay. And then, okay, in a trapezoid, this is a quadrilateral, right? Which means that total internal angle has to be 360, right? We already know that 180 gets taken up from here. Okay, so all of these, right? So A plus B plus C plus D must be equal to 180. Uh-huh. Oh, well, we already know that. Because A plus C equals 90. B plus D equals 90. Okay, well, that didn't really help us out, did it? Oh, damn it. Okay. Yeah, cool. Great. A plus C is 90. B plus D is 90. I need a third. Yeah, I know that doesn't really help us out much. We need another relationship here. Be nice if I had something like. One sec. Okay, well we know what this is, right? So this right here, right? This is 180 minus A plus B. That has to be what this is, right? And then plus A plus B must equal 180. No, that just gets me A plus B equals A plus B. I was trying to see if like if whatever. So this is like right. That's the 180 minus A plus B. And then that plus A plus B would also have to equal 180, but nah, that doesn't do anything for me. Close. Close. Close, close, close. Geometry proves things you already know. I agree. It does sometimes. Well, I see some tangent relationships, right? Well, not really. Ew, because yeah, I only know this side, and I only know this side. I don't know what this side is. So is the goal to stump the teacher? Sometimes. Jamarcus usually does, because he can't even solve these questions. The teacher doesn't even give him solutions. These are like really, really intense like challenge problems for like math puzzle stuff. Yeah, maybe. There's another circle theorem thing here going on. Has to do with this being tangent. It's like, yeah, you know what I think it is? Okay. I think because this, Jamarcus, maps out... No, but that only works if it's the same segment inside the circle. Like, there's something where, like, if the interior angle maps out the same segment, then the angles must be the same, right? What is that? Same segment... It's like this. Like these angles are the same because they match the same segment. But I think it's only within the circle. If you connect AC and BD, or if we connect AC, yeah, but the issue is that this is outside the circle, right? Nice. This is not inside the circle. Oh, what's up, Richard? Appreciate it, dude. Yeah. That's the issue. Is that these A and B are outside the circle. I don't think that works for the same segment theorem. It's like this. This is another one. It's another one that's kind of useful sometimes. So that says that, okay, so watch here. So the distance of the tangent, right, is equal to, so this squared is equal to this EC times ED. So in this case, if we were here, right, the tangent length is equal to this much times the whole thing. Doesn't really help me very much there to just get that amount. I don't really think I want that. But then I could do the same thing here, right? This distance is equal to this distance times the whole thing as well. I just don't think I want to get into that. It would be nice, I think, to know this and this. Because I think once we know those distances, then I'm just gonna use like similar trapezoids or something. Option 3, give up. Yeah, I might have to on this one, honestly. If anyone else thinks they can solve this, please chime in if you think. The other problem here is that like I wasn't really given a diagram, so I hope my diagram's correct. Yeah. We're close, man. We're close. But yeah, let me make sure we have time for other students that are asking questions. The new lore character? Who's the new lore character? Who's the new lore character? What? Okay. Here, let me do Josue, because Josue's been waiting, and I'm guessing that Ethan's question is also going to be like a really difficult challenge question. So, but Josue's looks like actually doable. So here, Josue, do you want to work? Yeah, let's do yours, dog. Because these kids giving me like these ridiculous like Russian challenge math questions is hurting my brain right now. I will do yours next, Ethan, but I think yours is also a similar like difficult challenge question, and I'd rather help someone out with something which I think is their actual homework question first before like I start banging my head against like challenge questions.
Okay then.
Cool. Josue, what's up, dude?
Hello.
Hey, okay, nice. Okay, equation of a sphere. I like this. Yeah. Taco Cat says, help me. Taco Cat, what? I did help you earlier, Taco. You chill, dog. Yeah, okay. Okay, equation of a sphere with points P such that the distance from P to A is twice the distance from P to B. Oh, okay.
This
With
is
points.
Calc 3.
Okay. Calc 3. Okay. Well, at least it's not like ridiculously hard math question from Soviet Russia that was meant to just like break children, you know? It's not that.
No, not that.
Yeah. Okay. Find an equation of a sphere with points P such that, so this is, A is not on the sphere, right? A is just some random ass thing somewhere, right?
Point, yeah.
It's twice the distance with points P. So is there an equation for the distance from a sphere to a point?
That's the square root, and then you do like the squares.
Sure. With points P. But, like, okay, when I see the equation of a sphere with points P, P is, like, all the points on the sphere, which is, like, everything, you know? So we're saying that, like, P can exist anywhere on the surface of this sphere, and we're saying that the distance from somewhere on this sphere to A is twice the distance of that same point to some point B, I believe. Unless this is worded wrong, you know, which does happen, man.
Yeah.
Yeah, just check for me that the wording's okay on this, because that does happen. Also, are points P specifically on the sphere, or can they be in the sphere? No, usually they're on the sphere. So the equation of a circle and equation of a sphere describes everything on the manifold on the outside. That's usually what it is.
I think P2A is the radius of the sphere. What it's trying to say.
Okay,
What it's trying to-
I think. Well, I think I see like some hints here, which kind of makes sense. Make more sense. Okay. So yeah, let's consider we just have some random ass point P on a sphere. Okay, which is equal to x comma y comma z. All right. Then the distance from A to P, right? So AP would be equal to the square root. Yeah, you said it, right? So this would be like x plus 3 squared plus y minus 6 squared plus z minus 3. Okay. And then the distance from P to B, or let's just say B to P. Let's just do this. Well, I should have done this, sorry. P to A, right? Because it's y2 minus... No, sorry. A to P. Okay. And then B to P, that's equal to... x minus 6 squared plus y minus 2 squared plus z plus 1 squared. Right? Okay. But then I say that this distance, right, is twice this. So this is equal to 2 times of this. Okay. So this equals twice this. Yay. That's a mess. Okay. I'm gonna square both sides because I don't like the square roots, right? Let's just get rid of these, right? Okay. So thank God for copy paste, because this is gonna go away. And then this is gonna have a 4 on everything. If that makes sense, right? 4.
Yep.
Okay. 4. 4. Okay. Wow. I think the next step is to expand everything and then start combining like terms, right?
Yeah.
Okay. So let's just do it term by term. So this is x squared plus 6x plus 9, and then I'm just going to subtract these ones, okay? So then that's minus 4x squared plus what's that? 6, 12 plus 48x. And actually, I see what we're going to do. We're going to complete the square on a bunch of stuff. That's what we're going to do. I see what's going to happen here. Oh, this is too funny. Oh, yeah, thanks for the follow, Johanna. Yeah, okay, I see what's going to happen here. Okay. X squared plus 6x, okay? And then I'm just going to leave this in the register. I'm going to say there's a plus 9 here as well, okay? And then here I'm going to do minus 4x squared minus 48x, right? Or plus 48x. Because 2 times minus 6 is minus 12 times x minus 12x times 4 is 48x, but then we're bringing it over, so it's plus 48x, okay? And then there's also a plus 4 times 36, okay, from this one. Okay, the y's, we got y squared minus 12y plus 36, okay? And then here we have minus 4y squared plus 16y, right? And then we have plus 16, right? Because 2 squared, 4 times 4 is 16. Okay. All right. Then here with the z, we got z squared minus 6z, and then we have plus 9. And then I have minus 4z squared, minus 8z, because z times 1 times 2 times 4, okay? And then there's a plus 4 as well, okay?
Yep.
All right, let's try to simplify all of these. So this real quick, this is going to be minus 3x squared plus 54x. This is going to be minus 3y squared plus 4y. And then this is going to be minus 3z squared minus 14z. Oh, man. None of this is pretty. These are gonna be a super pain in the ass to complete the square on, because they're thirds. But okay. And then whatever, we'll worry about all the radii later. This stuff's just gonna contribute to the radius. Okay, so then this is gonna be so if I pull out a 3 on everything, this is minus 3, and then this is gonna be x squared minus 18x, right? This is going to be minus 3, and then this is going to be y squared minus 4/3 y, right?
Mm-hmm.
This is minus 3 z squared plus 14/3 z. Okay. Okay, so then what I have to end up adding, right? Here I'm going to add 9 squared. Here I'm going to add 2/3 squared. And then here I'm going to add 7/3 squared.
Because it's half, right?
Yeah,
Or
take half square, right? But that means if I'm adding all this stuff on the left, right? Again, we got to add more stuff to the right. So here I have to add negative 3 times 9 squared. I also have to add negative 3 times 2/3 squared. And I have to add negative 3 times 7/3 squared. Okay? Because all of this is still happening on the left side. Okay? All right. Nice thing is now I get some nice stuff here. So I have minus 3, and this is going to be x plus 9 squared. Minus 3, oh, not plus 9, sorry, minus 9. This is going to be y minus 2/3 squared, okay? And then this is going to be minus 3 z plus 7/3 squared, okay? And then let's try to like solve what these were. So this was 9 and 9, that's 18 plus 36. So this gets me a total of 54, right? This got me 20 and 144, okay? So that's equal to 164. So when then this comes over, that's going to be 110 on the right. Okay?
Mm-hmm.
Okay. Now all this shit has to be added to it.
You minused it, right? Oh, 160.
Yes, I took the
took the
164, I minus the 54. Yeah, 110.
Right.
But then it's 110 minus 3 times 81, right? Minus 3 times 4/9 minus 3 times 49/9. Okay? This is going to be the whole right side here. So let's get some numbers. So that's 110 minus... We want it to be negative because I got a minus 3 in front of everything here too, which is kind of okay. Minus 3 times 81 minus 3 times 4/9 minus 3 times 49. Does this have to be an exact form? Do we remember? Whatever. Okay. Well, whatever. This is negative 150 and 2/3. Okay. And then we divide that all. We divide that all by negative 3. Right? Because you see, I have a negative 3 on it.
Negative 3's out of the way. Yeah.
Good. So then let's divide this by negative 3. What is 0.22 repeating? Is that 2/11? Or is it 2/9? Oh, it's 2/9. I think wait 1 second. What's 2 over 9? Yes, okay. So this gets me x minus 9 squared plus y minus 2/3 squared plus z plus 7/3 squared is equal to 50 and 2/9, which is 452/9. Okay. Okay. And is it x squared plus y squared plus z squared is equal to, is it r squared or r cubed? I forget.
To find the radius is squared.
It's squared? Right, okay. So then the radius is equal to the square root of this, right?
Yeah. Yeah.
I don't know what the square root of 452 is. But you can probably just write it out as this, right? It's the square root of 452 over 3. Okay. Is that the radius? And then I think your coordinates is 9, 2/3, negative 7/3.
Yeah, I see where I messed up now.
Is that right though?
Oh, I can check right now.
Yeah, check for me, please. I need to close the loops on this one. God, this one was a mess. Thanks for the follow, Moon Patrol. What's going on, my guy? 838 followers. We're getting up there, dude. Yeah, so it should be 9 2/3 negative 7/3, and then hopefully the square root of 452 over 3. I think. Man, I hope it is. There's a lot of math. Ugly but doable, yeah. Could use that word for a lot of things. Ugly but doable. Okay, good to see you, Marcus. You're good, dude. I wonder if there's a solver for this. I'm trying to look at how other people do this, man. Yeah, no, it's just a mess. Oh, it's just a mess.
Yeah, that's right.
It is? Oh my god, thank you. Wow.
Yeah, I was working on this car for like 2 hours, and I couldn't figure out where I was going wrong, and you were just doing it, I was like, oh, that's part of it.
Oh my god, wow. Okay, here, I'll send this to you. Although, like, the way I'm doing this is kind of dirty, because I'm just like putting numbers, I'm just like, screw it, dude, like.
Oh, yeah, you're right.
Yeah, but yeah, dude, that's a fun one. Dude, how'd your physics test go, by the way, Josue? Remember we were working on that earlier? Not too well? Uh-oh. Do you get your test back at least? Like, can we like go over?
No, they don't give my test back.
Dude, what the hell? I don't understand that when teachers do that. It makes no sense to me.
Yeah.
Oh, okay. Well. Yeah.
But I do have some physics questions for tomorrow, so.
Good. Yeah, I will be streaming tomorrow. So yeah, bring them by tomorrow. Let's help you out with physics.
Yeah.
Cool. All right. Thanks for waiting, dude. Jose, I appreciate it, dude. It was a good question.
No, thank you.
You're welcome.
Nice.
Ethan, what's up? Let's do yours. Last question of the day. Let's see if I want to do this one. I'm getting tired. What's up, Ethan?
Yeah, I'm here.
Okay, man. Good. Yohanan, what's up, Yohanan? Yohanan Ho. You want to say something, Yohanan? Yohanan Ho. All right, let's see. Diagrams show PQRS. Oler says the problem for me, a problem like this is a test would get bought. Yeah, dude, that's not a test question. No. This is not a test question. This is a homework question. This is just brutal. But it goes over some. It goes over some good concepts. So it's completing the square, equation of a sphere. These are all important things that you learn in earlier classes, and you have to be able to use in today's stuff. Okay. PQRS with edges of length 1. Oh, it's a square. Okay, sorry. Okay, so this has a length of 1. I like that. That's cool. Awesome. And 4 arcs, which each is a quarter of a circle. What? Where are the 4 arcs? Taco, didn't we do your question, dog? Like, are you trolling me, dude? Dude, what? God damn it, Taco, dude. You are trolling me. Okay. Arc TRU has center P. Okay. And arc VPW has center R. And arc UV has center... okay. Alright. I'm just trying to understand what's going on here, dog. What? What are they doing? Okay. So this has a center here, right? This right here.
Like
Is a set.
You do not want to do it. You cannot do it.
Oh, I don't know. I've never done this question before. We're gonna figure it out. I'm just, I'm just drawing some pictures so I can understand what's happening right now. Okay. What is the length of the perimeter of the shaded region? Oh, okay. That's fun. VPW. Ooh, okay. Okay. Okay, so, yeah, if these are the centers of these arcs, that tells me that these sides are the same at least, which is cool. So that might help us out a little bit. I know that this equals this, right? And I know that this is equal to this. Okay. Cool. And even more so, here's another cool thing, Ethan. Because this is an arc here, this side is equal to this side, okay? So let's call this missing side X. I don't know what this thing X is, right? Okay. But because this has to equal this, and I know that this and this are equal, that means this and this are equal. So this is also X. This is X. Okay. Cool. All right. Oh, this is easy, Ethan. We got this, man. This is so easy. Thank you, Zen Brazil. I think I see it. Okay. Because do you see how this is 90 degrees, which means it's the quarter of a circle, okay? So it's a quarter of this circle and it's a quarter of this circle, but they're the same circle. Okay? So so it's really half a circle of radius 1 plus x. So okay, so 2 pi 1 plus x, that's the length of this and this. But then but divided by 2. So it's just pi. Pi 1 plus x. That's going to be what the length of this and this thing are. I think.
But X is unknown.
We don't know that yet. Okay, we're going to get it. Okay, and then this is again going to be pi times x, because it would have been 2 pi x over 2, but that's just pi times x. Okay. Last thing we gotta do is find x. All right. How do we get x? Oh, you know how? I know how we get it, Ethan. This is cool. Very cool, dude.
Tell me.
What's the distance from here to here? You see how this distance is the same as this distance, which is the same as this distance?
Yeah.
Okay. I know that this is 1, this is 1. What is this going to be?
Have to go.
Yeah.
You're not hearing anything?
I hear you. What's up?
I'm hearing something from Utsu. I'm hearing a lot of static.
Oh, it's okay. I'm turning it down. I fixed it. Here, I'll just move in the audience.
Okay.
It's okay. All right.
That was creepy.
It's easy. Okay. So, do you see how this is the diagonal of a square, okay? Which has lengths 1. So, what's the length of this diagonal going to be?
1.
No. If we got a square that's like this, Ethan, right? 1, 1. What's this side?
2.
Square root of 2. Pythagorean theorem, right? 1 squared plus 1 squared is equal to c squared. 2 is equal to c squared. C is equal to the square root of 2.
Oh, okay.
Okay? So that tells me that this, which is the same as 1 plus x, right? 1 plus x is equal to the square root of 2. All right? So x is equal to the square root of 2 minus 1. Now watch what happens. So this becomes pi times the square root of 2 plus pi times the square root of 2 minus 1, which is really just pi times 2 square root of 2 minus 1, which is choice B. Nice. That's a cool one.
Okay then.
Wow. That's a super cool question, Ethan. I appreciate that one. That was really cool.
That you actually got it correct.
I did. Oh, you know what the right answer was?
Yeah.
Yeah.
I have
Nice.
an explanation for it.
I think we got it. We got the explanation. Monkey, wait, Monkey, did you really have another question,
Yeah.
dog? Taco Cat, I thought we did yours, dude. Taco, I did yours. Yours was. Don't troll me, please, dog. We did this. This is your question, Taco. Yes, thank you, Taco. What's up, Ethan?
Yeah. Yeah, it does have similar stuff saying about Pythagoras' theorem with square root of 2, but then they have a fraction of like 1/4.
Yeah, so because each arc there was a quarter of a circle, that's why it's 1/4. But then there is a pair of them, so that's why I said it was half.
Okay.
Okay.
Also,
What's up, dude?
you didn't check the good grades.
I still need to do it. I did the fitness, but I got to do the good grades because it's also the end of the month. Don't worry, I'll get to that today or later tomorrow. I'm still getting back into the swing of things.
What? You said today and later tomorrow? What?
I will get to it either later today or I will get to it by tomorrow.
You said either today or later tomorrow. That was not making sense.
Yeah, well, I'm tired. It's 2 hours. Okay, cool.
I get it.
All right, I think that's it for questions. So again, yes, thank you everyone for coming to Office Hours. Had a fun time going through all your questions and stuff. Again, yeah, if you found us on Twitch, join our Discord. Link is somewhere. Or here, I'll just, there's the link. Yeah, you're very welcome, dude. That's the link. That's our schedule. And then if you want to know any other cool math streamers, these are our math streamer friends. Yeah. Which I think we'll go raid one of them. Is Penn Center streaming right now? Let me see. Who's streaming right now? Oh yeah. Well, wait. What? Penn Center's playing the Ocarina of Time. Oh well, we don't want to play the Ocarina of Time. Science is still starting. Is his stream still starting? One sec. Let me see what Science is doing. Science is cool. We like Science. Let me see what Science is doing on his stream. Oh, they're starting theirs in 4 minutes. Oh, okay. All good. Yeah, let's raid Penn Center. Yeah, we'll go say hi to Penn Center. Let's go raid Penn Center. Yeah, it's okay. We don't have to do Science today. Okay. Anyways, all right. Yes, thank you for coming. Our next stream is going to be tomorrow. That'll be an hour later, starting at 5 p.m. 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. So if you want to come on by and learn more with us there. Yeah, thanks, Don. Appreciate it. Yeah, we had some good questions today. And yeah, we'll do some more questions tomorrow. Hope you have a wonderful rest of your Tuesday. It's Tuesday? Yeah, okay, it's Tuesday. Go say hi to Penn Center. He's a really cool math streamer of ours. And he is playing The Legend of Zelda. Old school classic game. So if you want to go say hi to Penn Center for us, he's a real good friend of mine. All right, cool. I will see you guys tomorrow. Peace.